This is lesson 3.5 out of the Introductory to Algebra book. In Mrs. Walker's classes is page 78. Lesson 3.5 is titled, I'm going to do some abbreviating, Solving, Multiplying, and Dividing Equations. So this lesson is actually pretty easy because it's a continuation. If you've already been through our lesson 3.3 and 3.4, which were combined, this is the same thing, only now we're dealing with the operations of multiplying and dividing. So notes are really short and concepts pretty easy to grasp. Let's start with warm-ups anyway. So we've got warm-ups. And the instructions for our warm-ups, just like what we did in 3.3, 3.5, solve each equation, and of course, check your solution. So, the first one is m plus 72 equals 100. The second one is 220 equals y minus 101. Third problem is a minus 6 6/10 equals 8 9/10. And number 4, let's see, am I still in frame here? There we go. Number 4, x plus 84 equals 233. All right, so those are your warm-up problems. Work those out, get your brain working so you know what we're going to be doing in today's lesson. All right, well, here's what we're doing in today's lesson. Here's our I can statement. I can solve equations. I can solve equations involving, and I don't want to have to go into a second line, so I'm going to just abbreviate here, involving multiplying and dividing. Okay, that's what we're doing. So with my dark green pencil, kind of underlined here, and we're ready to start the notes portion. So let's see, I think I got my dark blue pencil, and it doesn't really matter. You could use your purple, dark blue, whatever you like. But we need to write a couple of important things here from, you'll remember from our notes from 3.3, we talked about inverse operations. And the inverse operation of addition is subtraction. And the inverse operation of subtraction is addition. Well, now we're talking about multiplication and division. And I don't want to have to glue in a notes on this one because it's just too easy to write and we can save some space. So here's what we're going to write. The inverse of multiplication is division. Okay. Conversely, or the opposite, the inverse of division is multiplication. Multiplication. There we go. All right? So as long as we know that, then we can understand what's happening with our examples. So notes are so short on this lesson. I'm really only going to give you 2 examples and then 1 explanation for something that'll look a little new to you. All right? So here it goes. Problem number 1, or example number 1. Okay, we have 4p equals 48. All right? Now, same as what we learned before, this variable p wants to be in its house all alone. And 4 is hanging out here, and we want 4 to be gone. And so what do? Well, 4p means 4 times p, 4 multiplied by p. So the inverse of multiplication is division. So to get rid of the 4, we divide it by 4. All right? Because 4 divided by 4 is 1. And we would then have 1p. We don't show the 1 in front of the variable. And so that would mean then that the variable p is all by itself. So by dividing it by itself, we have evicted it. And now p is all by itself, just like it wants to be. All right? So, but same as always, what we do to one side, we have to do to the other. So we have to divide the other side by 4 as well. So 48 divided by 4 is 12, right? So I think that p equals 12. But what do I have to do? I have to check my work. So I rewrite this equation, inserting 12 for my variable. So that means I have 4 times 12 equals 48. I carried down the equal sign, keeping them equal sign, keeping them lined up, and the 48. Now 4 times 12 I know to be 48. 48 equals 48. Yes. So check. That is my solution. All right. So that's how you do a multiplication problem when you're solving an equation. You have to remember that what looks like a fraction symbol to you really means division. Okay? This divided by this. All right? So to get rid of the 4, we divide it by itself. That turns it into a 1 and makes the variable all by itself. All right? So let's see what it looks like in example number 2. Example number 2. The equation is x over 9 equals 5. All right? Now, x over, I see x over here. Oh, let's build the fence for x. All right? I see x here, and 9 is hanging out in his house. We need to get rid of it. This is division. And I know that the inverse of division is multiplication. So I have to use multiplication to get rid of 9. I'm going to use the little dot as my multiplication symbol and put 9 up here. I'm going to show you later why I put 9 up here. Just hang with me right now. I'll show you later why that happens. All right? 9, when I put it up there, evicts the 9. And now the x is all by itself, just like it wants to be. But what you do to one side, you have to do to the other. So if I've multiplied x over 9 by 9, then I also have to multiply 5 on the other side by 9. So 5 times 9 is 45. So I have solved this equation, I think, to mean that x equals 45. And I have to check it. So 45, I plug in for x over 9 equals 5. Okay, keep the equal signs lined up and bring down the 5. 45 divided by 9 is 5. 5 equals 5, yes. So check, it's true. Okay, so what is happening with this 9? How does this 9 get rid of this 9? I'm going to take my light green pencil and just kind of make a little side area where I can explain that. How does that happen? All right. All right. So if I had x over 9, like I had right here, and I multiplied this fraction by 9 over 1. Remember, any whole number, when you put it over 1, can be a fraction, right? Well, if I multiplied these two fractions, I get 9x over 1/9. Correct? Well, 9 goes into 9 one time, which equals 1x. But we don't show the 1, and so it would simply be x. So when I put the 9, I put the multiplication dot here and the 9 here and then cross them out. It's the same thing as crossing out these. And then I simply have the x all alone. That's a tricky one, I know, for some students to get, but just trust me, when you see a variable over a number, that's division, so we have to multiply. Put the multiplication dot there, and whatever is in the denominator here, whatever is doing the dividing, put that same number right up there, cross them out, and that's the number you'll multiply over on the other side, because what you do on one side, multiplying by 9, you have to do on the other side, multiplying by 9. All right? So it's tricky, but this is why that works. You have to think about how we multiply fractions, and that's why that works. 9 goes into 9 one time. That leaves us with 1x, which really means x, and that's ultimately what we want, x all by itself, which is what we got down here. Okay? So that's the whole lesson. That's it. I know most of our lessons are much more involved and longer than that, but that's it. So what it's going to take now is some practice. You have the examples of the two different types of problems that you'll be doing on your worksheet for this lesson. And so I've set up some practice problems that we'll use to practice, and then that's it. That's what you'll have on your worksheet. So let's do that. Okay, these are the practice problems for lesson 3.5. Let's see, how many can we get into frame? I can get the first 3. There's 4 problems. So here are the first 3. Pause and work these out. And the last one is right here. Okay, let me show you how we do these. Remember that we solve the problems and check our solution. So we'll start with this first one. M over 8 equals 3. Well, this fraction bar tells me division, and the opposite of division is multiplication. So I'm going to build my little fence here, my little upside down T, so that M is in his own house, but 8 is in his house, and we need to get rid of that. The opposite of division is multiplication, so I'm going to put a little dot multiplication symbol there, and the 8 up here, the 8 from down here. And when I do that, I can then cross them out. 8 has been evicted, gone. M is all by itself, just like it wants to be. But what we do to one side, we have to do to the other. I had to multiply this fraction by 8 to get rid of the 8. So now I'm going to multiply this 3 times 8. So 3 times 8 is 24. And so M equals 24. And I believe that's the answer. But I have to prove it. So over here I'll do my check. So I plug in 24 for my variable. 24 over 8 equals 3. All right? Well, keep my equal sign lined up and bring down a 3. 24 divided by 8 is 3. 3 equals 3. So check, my solution is true. All right? Okay, so number 2. Okay, so number 2, we have, well, again, let's build our fence. Y is over here on this side, and 3 is in Y's house. And we need to get rid of 3. So, I see a division symbol here. This fraction bar is a division symbol. So that means I have to use multiplication to get rid of the 3. So I'm going to multiply that 3 by 3. And I cross them out. 3 is now evicted. Y is all by itself. But what I do to one side, I have to do to the other. So I have to multiply, and it's kind of tricky because it's all close up here. So I can say multiplied by 3 like this. And that'll make it easier for me to figure out how to multiply 6 2/10 by 3. So 3 times 2 is 6. 3 times 6 is 18. There's only one digit past decimals in these two numbers, so it's going to go right here. So I think y equals 18 6/10. So I have to check that. So over here, I'm going to rewrite this equation. 6 2/10 equals, I plug in 18 6/10 for y. 18 6/10 over 3. Keep the equal signs lined up. 6 2/10. All right. So I'm going to have to do some scratching out to the side here to figure out what is 18 6/10 divided by 3. Right? I mean, you might not have to. You might be able to see it. Okay, but let's be sure. All right. So 3 divided into 18 6/10. Keep that decimal sign straight up. So 3 goes into 18 6 times. 6 times 3 is 18. Okay, 0. Bring down the 6. Okay, 3 goes into 6 2 times. 2 times 3 is 6. 0. So 3 goes into 18 6/10. 6 2/10 times. So 6 2/10. 6 2/10 equals 6 2/10. True. So my answer checks out. Y does equal 18 6/10. All right. Decimals makes it a little bit trickier, but we can do it. All right. So number 3. 11p equals 99. All right. Well, let's get this straight. Here we go. Build the fence for our variable's yard. All right. 11p means 11 times the variable p. So the inverse operation for multiplication is division. That means I have to use division to take care of this. So I'm going to divide this by 11. That then gets rid of 11 and gives the variable p all by itself, just like it wants to be. But what I do to one side, I must do to the other. So I have to divide this side by 11 as well. 11 goes into 99 9 times. So I think I have solved this equation with p equals 9. But I've got to prove it. So 11 times, I insert 9 for the variable p, 9 equals 99. All right, we keep the equal sign lined up, bring down the 99. 11 times 9 is 99. 99 equals 99. Yes, in fact it does. Check. My solution was correct. All right, and the last one. 12x equals 60. Well, here's my fence. X has this roommate 12. He would like the roommate to go away. So we've got to do that. 12x means multiply. So the inverse of multiplication is division. We get rid of that x by dividing, we get rid of the 12 by dividing by 12. So now that's gone, and x is by itself, just like it wants to be. What we do to one side, we have to do to the other. So we're going to divide 60 by 12 as well. 12 goes into 60 5 times. So I think x equals 5. But of course I have to prove it. So I rewrite this equation. 12 times x is 5, I think, so that's what I'm going to plug in, equals 60. I keep my equal sign lined up and bring down the 60. Now, what is 12 times 5? I know that it is 60. 60 equals 60. Yes, it does. So check, my solution was correct. All right, so that went kind of fast. The beauty of video is you can just keep replaying and replaying and until it clicks, until you get it. So let's take a peek at your worksheet. The worksheet for this lesson 3.5. The top is solve each equation using inverse operations and check your solution. So just like the operations we did, the examples that we did in the notes and in the practice problems are what you'll see right here. The second part of your worksheet, as you've seen in previous examples, it's the same, it's just you have to write the equation from the word phrase first, then solve it, and on these it says solve the equation. It doesn't say to check your solution, but that's never a bad idea. All right, so that's your worksheet. Now, your exit ticket for lesson 3.5. As always, I don't tell you how to do this or give you the answers. This is extra practice for you, or maybe your teacher will use it as a way to quiz you or test you. Okay, so that's the end of lesson 3.5. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.